Okay, so on to homework number 6 over scientific notation. So I guess let's go ahead and jump in. So I guess some words about scientific notation. What makes something in scientific notation is the fact that we're multiplying by some power of 10. So when you see that multiplication by some power of 10 and that piece that's being multiplied by some power of 10, that piece has to fall in between 1 and 10. So 1 is good, 10's too much, it has to be 9 or smaller, which through some examples, hopefully that will make some sense. So this scientific notation is the multiplication by powers of 10, and the thing you're multiplying by a power of 10 would be a number 1 through 9 inclusive. Inclusive meaning it can be 1 and it can be 9. In fact, it can be 9.5. It can be greater than 9. It just has to be less than 10. You can't say 10 times 10 to the negative fifth. That is not proper scientific notation. That piece that's being multiplied in front of the power of 10 needs to be strictly less than 10. So 9.9999 is good. 10 is bad. So let's go ahead and convert the following number from scientific notation to ordinary notation. So 2 times 10 to the negative 5. Well, 2 times 10 to the negative 5, so essentially what we have here is the number 2. And this would be written out as, you could look at it as 2.0, so recognize there is a decimal place present, even if it's not explicitly listed. So you can look at 2 as the number 2.0. Now doing this is simply to introduce this decimal point, because when we're multiplying by powers of 10, it's essentially moving this decimal point. So the question becomes, where are we going to move it? Well, we're going to take this decimal point and we're going to move it 5 spots to the left. So 5 places to the left. Why 5? Well, we have a power of 5 on our 10. Why to the left? It's negative. So multiplying by a negative power on 10 gives you a smaller number in its essence. So we're going to take 2.0 and we're going to move this decimal place 1, 2, 3, 4, 5. 5 spots to the left. And all of these blank spaces we will fill with zeros. Now, this last 0 we introduced strictly to show where the location of that decimal point originally was. So let's go ahead and forget about that 0 that we introduced. So our solution looks like 0.1234 zeros, 1, 2, 3, 4 zeros, and then the number 2. Moment of truth. 0, simplify your answer, type an integer or a decimal. Okay. 0.1234 zeros followed by a 2. Moment of truth. Ayo, we got it. All right. Similar type of problem here. 3 times 10 to the negative 4 is 3. Here was our decimal place originally. 1, 2, 3, 4. So the solution is point. I don't like starting with a decimal place. You should always start with the number 0 and then go point. So 0.000 and then 3. Moment of truth. Ayo, got another one. All right. Convert to scientific notation. So similar idea, just going the other direction. So we have 3600 and we want to write this as a power of 10, well, this decimal place needs to be moved 1, 2, 3 spots. So we're going to be multiplying by a power of 10 with 3 is the power on 10 because we need to move this decimal place 1, 2, 3 spots to get our multiplicative factor that sits out front to fall in between 1 and 10. 3.6 falls in between 1 and 10, so this looks good. The big question is, well, how do you know if this is a -3 or a +3? Because up here you said we moved the decimal place to the left, and that was a negative exponent. The thing to keep in mind is you can always punch this into your calculator, 3.6 times 10 to the +3, and you'll end up with 3,600. And then you could contrast that example by multiplying 3.6 times 10 to the -3 and see that's no good. So really the best way to compartmentalize, is this exponent going to be negative or positive? It's a matter of inspecting your numbers, and right, 3.6 needs to get bigger to become 3,600, so it should be a positive exponent on the 10. Up here, for 2 to become 0.00002, the number had to get smaller, so hence negative exponent on 10. So, and again, you can always type in this scientific notation and see if it produces the number that you're looking for. So, moment of truth, 3.6 times 10 raised to the 3. Hopefully it'll like my notation. Maybe it won't like the dot, but we'll find out together. Use multiplication symbol in the math palette as needed. We'll see if that's true. And you can use the multiplication on your keyboard, it looks like. So, all right. 430 converted to scientific notation. Well, that's 430. Here's our decimal place. We need to move it 2 spots to get 4.3 times 10 to the 2. .3 times 10 raised to the 2. Again, you can type 4.3 times 10 to the 2 into your calculator and you will get 430. So the thing to keep in mind is keep track of how many spots you need to move that decimal place. The number of spots is going to equal the magnitude of this exponent, and then it's a matter of reasoning through, does that need to be a negative exponent or does it need to be positive? All right. I'll see you on the next one.